So does it let you? Does it have a graphing on here? Does it let you graph it? But it doesn't let you plug in the numbers. Okay, so you got to actually plug in some numbers and see. Uh-huh. Well, what I'm going to do for this one is I'm going to plug in 0 for x, 1 for x, and 2 for x and see what math I get. And then I'm going to have you plot those points and then use that little graph button to graph it. And then we'll get the domain and range after we get the graph. So I'm going to... Do you want me to show you that work? I think my document camera is a little bit better today. You'll be able to see it if you want me to show you.
Sorry about that. Man, that was a hassle. Yeah, just share with me. Yes.
Alright, so I'm going to plug in 0, 1, and negative 2 into x. Well, those are just pretty much generic numbers for x along the x-axis there. And that'll give me a good idea of what plots the point and give me a good idea what the graph is going to look like. So if I plug in 0 for x, that will give me 1/3 to the negative 2 power. But the thing is, you're going to have to evaluate what 1/3 to the negative 2 power is. So if I do 1/3 to the negative 2 power over 1, that's the same as 1 over 1/3 squared. I'll try to show you picture this math. Because it looks like it's not letting you use a graphing calculator. You got to do the math yourself here. So there's my first picture. So So that gives me 1 over 1/9, which is 1 times 9 over 1, which is 9. Again, all it is plugging in 0 for the x, getting that -2, realizing what a negative exponent is. And then that last picture coming through right there is it simplified. The x number, yeah, that's the y, so that's the 0.09. So that was 0 for x, and then when I plugged it in, I got 9 for y. Alright, so now I'm going to plug in 1 for x, and that's going to give me 1/3 to the 1 minus 2 power, which is 1 over 1/3, which is 1 times 3, which is 3. Again, it's this, you got to know your negative exponents, plugging it in, and how to simplify negative exponents. So that picture coming to you, when I plug in 1 for x, I get 3 for y. There you go. And then if I plug in 2 for x, that gives me 1/3. I'm going to plug in +2. That gives me 2 minus 2 power, which is 1/3 to the 0 power, which is 1. So that last one there, when I plug in 2, it gives me the y number 1. So that's the coordinate 2, 1 for that one. And then X that out and try to plot the line through those. I think it's that. Ooh, that's weird. So hit that. So it's going to be, the asymptote's going to be right there, the x-axis. Right there. Perfect. And then, whoa, that's weird. Alright, so click X that one out, use the other one, the vertical one. Hit that one, and then do the first point up there at 9. You click that. 0, 9. All right. I don't know, but if you want to skip trying to do that and go straight to the domain and range, we could try to see if we could get the domain and range. Because the domain looks like it's going from negative infinity to positive infinity for my range, and that would be rounded brackets. And then my range goes from 0 to positive infinity. Rounded. There we go. I don't know about the lines. I mean, maybe it'll let you answer it without graphing it. I don't know. It's weird. Just try. Did you try to answer it without graphing it? Let's see. Alright, if I graph that on Desmos, let's see what that graph looks like. So that's 1/2 x, or 1/3. To the, let's clear that out, to the x minus 2 power, is that what it was? One third to the x minus, sorry, it's having problems here, x wow, Desmos. So it's curved downwards, right? Gosh, there we go. Right there. My graph shows like what we were doing, but it goes down to the right. I'm gonna take a shot at it. So I'm not sure why I didn't accept your ooh, look at that, you got it. Right there. Almost. I mean, the points were 0, 9, 1, 3, and 2, 1. So somehow if you could get that to yeah. No, it's maybe just go down the explanation on this one because we haven't got one right. And let's just see what it says. Alright, so they did 1/3. Let's take a picture of this. So they graphed it without the x minus 2. That's the transformation that moved it. Instead of up or down, when you have that on the exponent, that moves it right or left, I believe. So we moved it to the right 2 units. Take a picture of that. Okay, go down a little bit. So the domain range 0 to infinity. So go down to the answer. Yeah, because there's the 2, 1 point. there's the 1, 3 point. We had that domain and range answer. We had those 2 points. Because remember, no, I thought we did 0 to infinity. But it looks like you have to get that graph looking good too. So it looked like only use the points 1 and 2. That's what it looks like. I don't know. So it looks like you gotta somehow try to get the graph to look like that. We try that again. Let's try that again. I don't know. This is complicated. I'm gonna Desmos this first right away. So negative 2x so it looks like I get the points 1, negative 1 and 2, negative 3, and it looks like it has, I could see its range is negative infinity to 1, and its domain is negative infinity to positive infinity. I'm going to take a picture of that and send it to you. And then it's going to be up to you to try to get that on your thing. Let's see. That last one come in? Do you see it? Okay. So I would try to maybe Yep. Yes. And then try to, I wouldn't use that. I would X that out and just go straight to that line and try to, I would do the horizontal one. I wouldn't do that. I would use that horizontal, that one right there at 1. There you go. Nope, right there, positive 1. God, so what button? I would click out of that and use the one underneath that eraser. Not that one, the one, there you go. Perfect. So plot that one right there. Just that line, plot that line, perfect. And then the first point, go to 1, negative 1, over 1, down 1, almost there. Nope. Right 1, down 1, go back to the middle, and then from there, right 1, down 1. That's the first point. And then the second point is 2, negative 3. So right 2, down 3. That's too far. Right, and then down 1 more. Almost there. Oh, you were almost there. I was so close. Yep, right 2, down 3. So right there, you're at 3, negative 4. You need to be at 2, negative 3. Right there, perfect. Hit that, check that, see if that works. Alright, so it looks like we got them. Those plot buttons, whatever you want to call them. Yep, get good at Desmos for sure. 3 to the x power minus 2. It looks like I got a horizontal asymptote at -2. And one point is 0, -1, and the other one is 1, 1. Looks like we could nail it from there. Take a picture of that. So 0, -1 I see as 1 point, and then 1, 1 I see clearly as a second point to use. And then I see a domain of -infinity to +infinity, and then I see a range of -2 to infinity. So that should take care of that one. Not too bad. Because you can see that picture I sent you, or the one you're looking at, that's going left -infinity, right +infinity for my domain right there, if you want to type that in. So plot that at -2 first, get that dotted line at negative, perfect right there. And then first point is 0, 1. Almost there, gotta go down. Oops. 0, -1, there we go. And then 1, 1. Looking at the graph, looks like over 1, up 1 clearly. That's where it's intersecting right there, second point. There you go. And then your domain, you got -infinity to +infinity. And then range, that looks like -2 rounded to +infinity rounded. Yay. So 1/4 to the x plus 1. I had to use a bunch of parentheses. And then looking at 2 clear points, I see that horizontal dotted line. Use that one. Nope, not that vertical one. Horizontal one to the left of that. There you go. And then I would put the first point right there at 0, right in the middle. Perfect. And then first point I would put at -1, 1. If it lets you. Right there. And then second point's got to be -2, 1, 2, 3, -2, 4, if it lets you do that. There you go, -2, 4. Perfect, there we go, that's what I got. Yep. Measure from bottom to top. There you go. Alright, that takes care of that section. Be good at Desmos, and then know how to use that weird graphing stuff. She's doing good, yeah, thanks. Just, yeah. Alright, sounds good. So graphing, let's see. So is this the one right here? Alright, so it wants you to translate it. So what that means, if you're looking at that -1 for that bottom equation, that means you're taking that graph and you're moving it down 1 on the y-axis. And then that x plus 4 means you're moving it 4 boxes to the right. So the first thing I would do is take that and try to move it down 1 box. You drag that down 1 box right there. And then the next thing is you got to do is try to now click over 4 boxes to the right. Right there. Check that. So 1 down, 4 to the right. Let's go to the explanation. Let's see. I think we're close. Alright. So you can go down a little bit. Let's take a picture of that right there. Alright, go down a little bit. Hopefully you got a picture of that. Ooh, okay, so that's what it was. Instead of 4 to the right, it's to the left. Okay, so it looks like the opposite of what that number was up there. Instead of 4 positive, it was 4 to the left. And then it was still down 1. Alright, so we would have got it. I had it backwards, but we got it now. Piece of cake. Alright, so that x plus 4 means it's going to be shifted 4 left, and that plus 3 means it's going to be shifted up 3. So 4 left, 2, 3, 4, and then up 3 from there. 1, 2, 3. There we go. Oops. 1, 2, 3, 4 left, up 2. That should be good. So this one looks like 2 right, up 4. And then the number on the outside, you do what it says, either up or down. Yes. So yep, the x minus 2, the opposite of minus 2, plus 2 to the right. And then that plus 4, up 4. There you go. That should be good. Good job. One more of these. Right 3. Down 2. All right. It's up to you. I mean, I have lots of time. It's up to you what you want to do. Is this stuff that's due? So 20 total. Do you want to just try as much as you can on your own and see what you can do? And then if there's anything you're stuck on, let me help you. Or we could do it right now. I mean, it's up to you. These log ones? Alright, let's take a picture of that. Because these log ones really aren't that bad. You gotta memorize. Take a picture of that box. Yeah, take a picture of that. Because that's, you gotta know your log rules. And then scroll down a little bit. We're gonna use those rules with this problem right here. So it says they both have the base log 6. So by rule, that 2 out front becomes log 6 3 squared, which is 9. And then with that same base, they combine the 4 and the 9 there. I'm going to take a picture of that. So these, they're just rearranging where the numbers are going. Are you seeing that for that first example right there? So it took that 2 log base 6 3 and rearranged it where that 2 out front went by rule. That became log 6 3 squared, so they rearranged it. And then they used that rule from that box that I had you take a picture of, where if the bases are the same, you could take those numbers next to it and times them together there. It's kind of confusing there. And then that gave you log base 6 36, which is log 6. Wow, that's really complicated. And then by rule, if you have the base is the same as the exponent, then by rule, wow. Alright, go down a little bit. So that equals 2. Alright, let's check out the second one here. Let's take a picture of that. So natural log equals 5 minus 2 equals 3. Wow. Alright. We could try some of these. I'm sure we're going to have to look at an explanation or two. And you're going to have to look at that picture that I had you. We're going to have to use that rule there. Logarithm of a product, logarithm of a quotient, and logarithm of a power rules. Alright. So 2e n to the fourth len. I'm going to take a picture of that. I'm going to change that to I'm going to take a picture of the first one I'm attempting there. I'm thinking it's good, but might have to learn on this one here. So that picture I sent you, I rearranged it first. I took it where that 2 out front, I switched it to the exponent. And then that gives me natural ln e to the 8th power plus ln e to the negative 11. Well, yeah, that's the first step, is rewrite it. Get that 2 from out front. You want that 2 out of there. And then this next picture shows, it's coming right here. Now that gives me natural log e to the 8th power. And then if you remember from that other picture, now those just equal 8 and negative 11. So if I take 8 plus negative 11, that gives me negative 3. Let's take a picture of that and send that to you. And I use this rule right here to get that as 8 and negative 11. Hopefully that's sent to you. Well, ln e to the 8th, by definition, by that last picture I sent you, is just plain old 8. And then that ln e to the negative 11 is just plain old negative 11. So if I add 8 plus negative 11, that answer in that box right there, I think you just got to type in as negative 3. And now that last one there, because the base 6 is the same, I'm going to use, what rule am I going to use? So I'm going back to that box I took a picture of where it says L log AM minus LAN is the same as, I'm going to divide those, so I'll show you. Log 618 minus log 618 minus log 6(3) is the same as log base 6 18 over 3, which is log base 6. Yep, I divided the 18 and 3 to get that as 6. And then by definition, the very last thing is, if I have the base log and that exponent, if they're the same, then that answer is equal to the exponent on that number. It's really complicated. So that answer just becomes plain old 1. Check that. Let's see. And again, they look way more complicated than these really are. I mean, you just gotta look at the numbers there. So that first one there, 2 natural log e to the 6th minus natural log e to the 5th. Do you see the first thing I'm going to do to get rid of that 2 out there? So that becomes ln e to the 6th times 2 power. So that ends up being natural log e to the 12th minus natural log to the 5th, e to the 5th. And then if you remember, once you get it in that form by that weird natural log rule, then those are just equal to the exponent answers. So that picture shows all the work so far. It's coming right now. So your last step on that is to just realize that natural log ln e to the 12th is just 12. And that ln e to the 5th is just 5. So that final answer is just 12, not plus 5 because it's minus there, 12 minus 5. Yep, so that should give you 7 for that one. Alright, now looking at these. This is adding, so I'm going back to that picture there. So you're gonna, that base, we call that the base of the log. So we're gonna leave that alone until the end. So this rule, let me try to send you this picture right here. I'm gonna send it to you again just so we're looking at the same picture there. And that should be coming. Here it comes. Yep, it's that first one, right? So that condenses down because the bases are the same, that log 14. I'm going to write that as log base 14. And I'm going to take that 2 and that 7 and I'm going to times them. Do you see that? So that'll end up giving me log base 14 times 14. And then if you remember by that other definition, once you get the base and that exponent the same, then it just equals the exponent of the exponent 1. Yeah, that should just be 1. I mean, if I'm going to show you something right here, let me show you this. Log 14, 4 plus log 14. I'm going to send you a picture. And that's the this one. I'm gonna try to show you what these problems are having you do. This last one right here. So if I take that, that ends up being log 14 to the 4 times 49 power, which is log 14 to the 96th. And by definition, 96 is 14 squared. So if I did that one right there, that answer would have been 2. That picture there, try to show you that. It's coming right now. So I take that 4 and that 49, I times them, and that 96. Then you gotta think of it as, you know, having to do with that 14 right there, and it is, because 14 squared is 96. And then once you get that base log and the other exponent the same, then it's just that 2 answer right there. So I don't know. You're gonna be doing those, I'm sure. Oh, look at that. But again, look at those. It's all exponent rules right there. So they broke it up into log of the top minus log of the bottom. They did that to the 1/2 power. They expanded that to the front. Go down a little bit on that one. And they broke that apart. Yeah, but again, it's all they did was just use those exponent rules, and they kind of broke them apart. So that log, by definition, division is the same as the top minus the bottom. And then they broke that up. I don't know, do you want to try a couple of these? Just knock out this section. Because these are pretty tough. Alright, so this log square root x y to the 7th over z to the 3rd. That is the same as ooh man, I should take a picture of that last one there. I think this is log. Let's take a look at okay, so I'm going to break that up into this. I'm going to show you a picture of that. So I'll do this step by step with you. Hopefully that first picture is coming. And then my next step, I'm going to write that log square root of x y to the 7th minus log square root z to the 3rd. And that I got from that little definition, that box of rules. Yep. And then I'm going to write that with, instead of a square root, I'm going to write it with an exponent of 1/2. That's my next step. I'm sending that picture right here. And then my next step, I'm going to bring that 1/2 to the front of both problems there. Which that last picture shows where the exponent used to be 1/2 up on top. Now I bring it to the front of both of those. And then my last step is to break that first one into 1/2 log base x plus 1/2 log y to the 7th. So that final answer is 1/2 log x plus.
Oh gosh, I'm so sorry. Did I just unplug you?
Plus 1/2 log y to the 3rd minus 1/2. Thanks. Sorry about that. Log z to the 3rd. That's what I get.
Ooh. Oh, that might have been from my coffee just now.
I did. Well, that middle one is positive because when I break that apart, by definition, that's adding. So the last answer is 1/2 log x plus 1/2 log y to the 7th, not 3rd, y to the 7th, and then minus 1/2 log z to the 3rd. Type that in, see if that works. Log x plus 1/2 log y to the 7th then that means they want that 7 brought down, so that would be change that 1/2 to 7/2, 7/2. Yep. And then get rid of that 7. That's what you could do when you bring that 7 down, times it by 1/2, and then minus 1/2. Ooh, so change that again. That's going to be 3/2 because they don't want that exponent on the z. Log z. I think that's it. Try that. Oh my goodness. Got it right. Sweet. Okay, log cubic root 3 x 5th y squared z. Okay, the first thing I'm going to do is write that instead of 3rd root, the 3rd root is to the 1/3 power. So I'm going to send you this picture right here. Because by definition, if it's a square root, that's anything to the 1/2 power. That one has a little 3 out front, so that's the 1/3 power. So I'm going to take that 1/3 and I'm going to bring it to the front. I'm going to write it as 1/3 log x to the 5th y squared z. So you picture that. And then I'm going to break that up into 1/3 log x to the 5th plus 1/3 log y squared plus 1/3 log z. And now I got to take out the exponents, so that times is that time 5 times is by 1/3. So my final answer, I'm thinking it's going to be 5/3 log x plus 2/3 log y plus 1/3 log z. I'm thinking that's what you're going to get. So that'd be 1/3. There you go. Yeah. No worry. So looking at that, I'm going to break it up into log x7 minus log z cubic root of y squared. So it looks way more complicated than it really is. So by definition, if you're logging something like a fraction like that, I'm going to write that as subtraction. So I'm going to send you this first picture here. Equals log x7 minus log. Here we go. So it looks like it's going to be using the division one, which is subtracting. Yep, this is the second one. Here comes the next step. That equals 7 log x minus log z y to the 2/3. Seven log x, and then the other one ends up being, I think, minus 2/3 log z minus 2/3 log y, I think. Ooh, that's a complicated one. log. That last one is just log y, just plain old y. I think we might have to double check that, but you can see you might get lucky. Yep. Ooh, that knocks out. Alright, so let's double check that one. So log x to the 7th minus log z y squared to the 1/3, which is log x7 minus. Can I try to show you on my screen just one more time? Can I try that, Sabri? Again, because it's just saying this, not doing it. Let's see. Screen sharing. Zoom share. Try it one more time here. Do you see that? Yeah, I'm not sure why it doesn't. Do you see that? You can. Do you? Do you see that? Is that focused? You can. Well enough to. Do you see it enough where you could follow along with what I'm doing? Okay. Because that first problem was log z. I changed that 1/3. So I'm going to write that as log z y to the 2/3 power. Maybe that was where my mistake was. And I'm going to bring this 7 down. And I'm going to bring that 2/3 down. So I'm going to write this 7 log x minus 2/3 log zy. And I think maybe it was because of this. That becomes 7 log x minus, in parentheses, 2/3 log z plus 2/3 log y. So that should have been minus 2/3 log z minus. Is that what we wrote? Ooh, you know what? I think. Let me redo that because I think this one over here becomes log z plus log 2/3. I think this is the way I should have really done that one. I should have split that log z y to the 2/3. I should have split that up into that first. And that becomes log x to the 7th minus log z plus 2/3 log y. I think that's better. So I think that final answer is log 7 log x minus log z minus 2/3 log y. Can you see that work right there? Wow. So I think that's it right there. I'm going to take a picture of it and then you can go back to your screen. Or can you type that in your screen without changing this? You can. Yep, try that. See if it works. You did? Sweet. So, what's the next problem? All right, perfect. All right, it's coming. There we go. So log. So I'm going to use that division rule. Yep. Which lets me break that into a subtraction problem. So I'm going to write that as log the top part minus log the separate bottom part. So log z to the 5th and that square root, that means that z to the 5th is raised to the 1/2 power minus log x to the 3rd y. Do you see that work there? So that ends up being log z to the 5/2 power. That's that little part right there. Minus log x to the 3rd y. And now I need to break up this part right here. I need to simplify that radical. So I'm going to write this as 5/2 log 7 minus, in parentheses, 3 log x plus log y. So it ends up being 5/2 log z minus 3 log x minus, because that minus distributes, log y. Hold a moment. I think that's good. 5/2, yes. Yes. It worked? Yay! Sweet. All right. Okay. So you are unlocked to move ahead to some of those? All right. Okay. All right. All right. Hopefully you will. Good luck. All right, lady. See you later.